Data centers are suddenly everywhere. Companies are spending billions building them, power grids are being reshaped around them, and somehow water ended up becoming one of the biggest arguments around AI. You'll see figures saying these facilities use absurd amounts of it, then another source will tell you the actual impact is being exaggerated, and both sides somehow have numbers to back themselves up. So instead of picking whichever headline sounds better, I wanted to look at what these places are actually using, why they need so much of it, and why we're building so many in the first place. Because apparently putting thousands of GPUs in one building has consequences. Let's get into it. Okay, so let's get this straight. Data centers aren't new. They've been around for decades. They're basically large facilities filled with servers, storage systems, and network equipment. The internet itself and pretty much everything we use online, like Netflix, iCloud, websites, online banking, cloud storage, games, and social media, all depend on them in some way. All of that information still has to run on physical computers somewhere. What has changed is the amount of computing power companies now want, especially because of AI. Normal servers were apparently no longer enough, so companies like Microsoft, Google, Amazon, and Meta are now buying specialized GPUs in very large amounts. Conveniently, NVIDIA spent years focusing on exactly this kind of hardware before everyone decided they needed as much of it as possible. Good stuff, Jensen. AI workloads can require a lot more processing power than many normal online services. Training a large model can involve thousands of GPUs running together for weeks or months. But training the model is only part of it. Once it is trained, you still need computing power every time someone actually uses it. Every time you send ChatGPT a message, generate an image, use an AI coding assistant, or use one of the many programs that now has AI added somewhere inside it, servers have to process that request. One person doing this means basically nothing. Millions of people doing it throughout the day is different. The International Energy Agency expects electricity use from data centers around the world to increase heavily over the next few years, with AI expected to make up a large part of that growth. So data centers are slowly moving from being something most people never thought about into major infrastructure that governments and power companies now have to plan around. And considering how quickly every company managed to find a reason to add AI to something, that demand did not exactly arrive slowly. So why does a data center even need water in the first place? The answer is heat. Computers generate heat whenever they're operating. Your PC at home already needs fans or some sort of cooling to stop the components from overheating. Now scale that up to thousands of servers, many packed with powerful GPUs running almost constantly, and suddenly you have a lot of heat that needs to go somewhere. One of the common ways data centers deal with this is evaporative cooling. Basically, water absorbs heat from the cooling system, and some of it evaporates into the atmosphere. And to be fair, this can actually be a very efficient way of cooling a large facility. The problem is, once that water evaporates, it's considered consumed because it's no longer immediately available to the local water system. In 2023, data centers in the United States directly consumed around 66 billion liters of water, which is obviously a lot. But this is also where the numbers start needing a bit more explanation, because there's direct water use and then there's indirect water use. Direct water is what the facility itself physically consumes, mainly through cooling. Indirect water comes from other parts of the system, mainly electricity generation. Data centers need huge amounts of electricity, and depending on where that power comes from, the power stations producing it can also use water for cooling. So when researchers calculate the full water footprint of a data center, they can include that water as well. So once you separate those two types of water use, the whole argument starts to look a bit different. Because yes, data centers can use a lot of water, but the bigger numbers people repeat are often measuring more than just what is physically being used inside the facility. A lot of it can come from the electricity system supplying it, and that still matters. It just means the number needs context before you decide what it actually tells you. And that doesn't mean the concern is fake either. If one of these facilities gets built somewhere that already has limited water or power infrastructure, then the local impact can be serious, even if the national percentage looks small. That's probably the part that matters more than just looking at one massive global number. Okay, if I'm being honest, it honestly is as bad as it sounds. If you came to this video thinking it was going to change the stream type, then I'm sorry. Maybe I can debunk it on the next one if you're still here. This video was done with an AI voice, if you still Donetsk. So yeah.